All right, so this is basically where we left off last time. We were talking about types, or values, pardon me, and how values had types. We talked about literals, how the number 7 and 42 and 97, they are all just like literally those numbers. They are, like at face value, they're literally what they are. But they have a type integer. And then there's like strings, A, B, C, D, E, F, G. That's just like any words, anything between quotes. And then there's floating point numbers, which are numbers, but they have decimals with them as well. And they all have a different type. And every value in the computer will have a type associated with it. What's interesting is some types, there might be like more values of one type versus another type. Like if you think about, well, this won't, never mind, this won't be true. But some things will have like very few values for a specific type. Something we're going to learn about soon is a Boolean. A Boolean can actually, like something of type Boolean can only take on one of two values, where an integer can take on like 0, 1, -7, 58, right? It could take on a lot of different values. Strings, a lot of different values, but Booleans can only have two. There's another type called a none type, which is basically a special value that the computer has. It's like this type that is used to represent nothing. And something of num type, the only value it can have, well, there's only one value it could have. It could be a none. But more on none later in the course. But every type, the point here that I'm trying to make is every type, every value has a type associated with it. Regardless of how many different values there could be, every single value has a type associated with it. And it's important to distinguish the types here because the type of the value has implications on how it works in different contexts. This is going to become much more clear as we go in the course. You're going to see a lot of examples of this. It's going to fill in very well. But just as an example, the integer 1 is very different than the string 1. Which is also very different than the floating point number 1. They all like look the same, but they actually have different, like they are actually different types. Now the float and the integer, yeah, they're similar in that they have the same value 1, but the string 1 is very, very different. So what I mean is like print 1, print 1, and print. They're all 1. They all look like, okay, the symbol is like a 1. The float's a little more obvious because it has a 0.0 next to it. And you'd say, well, they're all 1, but they're actually, yeah, but they're different. So be aware. And what's neat about Python is if you ever want to know what type something is, if you have some value and you're like, what type is this? You can ask. Like print was a function to tell Python to print something out. There's another function called type that gives you the type of whatever you give it as an argument. And I think this is best explained with an example. There are a lot of ways I could do this, but what I'm going to do for fun is I'm going to do print type of 1. And then down here, of 1, and then down here. You know what? For the sake of readability, let's do it like this. Now when I hit print, we see, well, the first one, it's a 1, but its class, its type, basically, is int for integer. The one with quotes, well, its class is str for string. And finally, the 1.0, well, that's class is float for a floating point number. So they all have a type. Now, I'm just going to show you this for the sake of showing you. I could simplify, I don't know if simplify is the right word, but I can modify this code. You can print out several things in a single line with a print. You just need to use a comma to separate them. So I could do something like this to maybe clean it up a little bit. And there, so now it's all on the same line. It's a little nicer, arguably, in terms of how it's output. But just as something to note here, we're nesting a function call, and then we're immediately giving the result back to the print. So print is a function that takes what we call arguments. So if I say print 1, the value 1 is the argument. That's what gets printed out. When I said type of 1, well, type is a function, and the argument, the thing I put in the parentheses, is a 1 here, and it's going to tell me the type of what I put in as the argument. But you'll notice that like I've got that type inside the parentheses of the print. So I've like nested a function call inside the arguments for another function call. This evidently works just fine, and it's kind of neat, and you might be taking advantage of this. But in general, some programmers might say, don't do that, because it's nice to have every line of code do like one thing, where this line of code is doing several things. I've kind of thrown this at you at this stage. This is a pretty advanced idea. This is not something you need to have memorized today. I'm just showing you. And all this stuff will become clear as we go. So any questions so far about anything? Okay. So for fun, yeah, do this one, especially because point 3 is interesting. Write a single line program to print out the integer 1, and then write another single line program to print out the string 1. And based on the output, can you tell the difference? I'll give you like 2 minutes to do this one. Shouldn't take very long. So here's part 1 and part 2 of that activity. Print out the integer 1. I know it's integer 1 because in the code it's just the number 1. And then on the second line, I know it's a string 1 because it's between the quotes. But you'll notice by just looking at the output of this code, you can't tell the difference. You can't tell, okay, was that an integer or a 1? Like which one's which? We'd have to know the code in order to tell the difference. It's important that we are very careful about our types. I talked about this last time. Some programming languages are very strict about anything you do with your values and how you have to explicitly mention the type of each value to make sure everything kind of works properly. Python is a little more loosey-goosey with the types. It figures it out on its own. But it's not perfect. It's going to make mistakes, and maybe you make mistakes, and it just interprets what you wrote exactly how you wrote it. And so when you're not explicit with types, that could be a recipe for bugs and issues that are kind of hard to tell because, just by looking at this, you can't tell the difference. The solution here would to be, like I just showed you, print out the type as well in order to know the type. But with Python, you have to be a little bit more vigilant about your types just to be safe to make sure other issues don't arise as we go. For the stuff we're going to be doing, we're going to be fine for the most part. I'm going to show you some of the common mistakes that come up at this time of learning to program. But it shouldn't be too much of a problem for us. But as we go and we learn more programming, like if you take next semester and more and more and more, as our programs get more and more complex, as the problems we're solving become more and more complex and more interesting, these types of issues become, I don't want to say more likely to happen, but like with the volume of code that you write, the volume of mistakes that can come up will increase as well. So we just talked about literals, and now variables. Now, usually we'd have talked about this before the first lab, but we didn't get to do that this year. So you're already all pretty much experts with variables. A variable, just like math, is something that like can represent some value that we want. It's like a stand-in for a value. Now, if I were to write, like in math, print x plus 5, right? If I were to write that and I were to say, what's the answer? You're going to say, well, I need to know what x is first, because it's just like, it's a variable. It's a stand-in for some value. Yeah. Same idea in Python. So variables let you store data with a label. And you can store values in variables using the assignment operator. The equals sign. Warning, the equals sign doesn't mean equals. Equals means equals, but more on that later. The equals sign means assignment in programming. So try to forget the last 15 years of math knowledge that you have and just forget what equals means for a moment. It means assignment, okay? So if you look at this code, I say A equals 5. All right? Now, on line 1, when I say A equals 5, that's an assignment statement. I am saying, okay, take the value 5 and put it into the variable A. And now, after running that line of code, A has the value 5. Okay? On the next line, I say m equals, quote, some string. Great. I took the value, it was a string, some string, and stored it in the variable m. So those are both variables. After this code is run, A, it's a variable, but it has a value associated with it currently. It's 5. M is a variable, and it has a value associated with it, the string, some string. So both variable A, let me show you. If I say A equals 5, A equals 5, print A plus 5. Get rid of that. When I run this code, let's get rid of this as well. I don't know why it's complaining. All right. There we go. What is this code doing? Well, line 1 says, okay, take the value of 5 and assign it to the variable A. All right. Then I'm saying, okay, print out A plus 5. What value does A have? It's not a trick question. 5. And then, so A plus 5 should be what? 10. Yeah, exactly. So we are saying print A plus 5. In this particular example, the variable A has the value 5, and the literal 5 also has the value 5. But one is a literal and one is a variable. Cool? Now here's where, and we saw this in lab, here's where, like, look, after this line of code, I'm saying A is an equals its assignment. And you'd say, yeah, but clearly after this line of code, A is equivalent to 5. Yeah, you're right, but if I were to go on and write something like this, A equals A times 2, suddenly, or no, let's make it even simpler, plus 1. Suddenly this is a little weird, right? If you're thinking of this as equality, you're like, okay, A equals 5, and A is somehow, A is also equal to itself plus 1, and A is equal to 5. What? That makes no sense. how can A be equivalent to 5 and also be equivalent to itself plus 1? Right? Clearly that makes no sense. That is like a logical absurdity. Right? How can A be equal to 5 and also be equal to itself plus 1? Like 5 isn't equal to 6. That's a ridiculous statement. Well, yeah, because equals doesn't mean equality. It's not a statement of fact. It's an assignment. So when looking at this code, the way we would interpret it is, okay, after line 1, we put the value 5 into the variable A. Okay, now we go to line 2. Now listen carefully. Any value, like the variable that we're assigning to, always is on the left-hand side. The right-hand side could be as short or as long as you want. Line 1 is very short. It's just 5. Line 2, well, there's a little bit more to it. There's like an operation involved, addition. The whole right-hand side gets calculated, it gets evaluated, and after everything's evaluated, then it gets stored back into the variable on the left-hand side. So if you were to think of the order of operations, like remember learning like brackets, exponents, multiplication, division, right? You remember learning that? Well, if you were to tack something onto that, assignment would be at the end. You do all of the calculations, and then finally, after everything's calculated, the last thing you would ever do on any line with an assignment is the assignment. So, line 1, A is 5. Okay, great. A has what value after line 1? Tell me. 5. Great. Line 2, A equals A plus 1. Okay, we evaluate the right-hand side first. What is A? 5. So what is A plus 1? 6. Great. We finished evaluating the right-hand side. The result was 6. Where do we put it? Back into A in this example. So A is now what? 6. So what happened to the 5? It's gone. We overwrote it. It's obliterated. It's as good as gone. Can't do much with it. Now I could do something like this. B. Well, now, in this example, A would still be 5. No, don't want that. A would still be 5, but B is storing 6. Okay, fine, cool. That's just what I'm doing. But beware, equals does not, it's not a statement of equality. It's not a statement of fact. It's assignment. So any questions about that? Okay. That's just me warning. So using variables. So here we go. Clearly, I could do like print 5 plus 6, right? If you were to say 5 plus 6, well, we evaluate the contents of the arguments there, the 5 plus 6. Well, 5 plus 6 is 11. So we just evaluated the literal 5 plus the literal 6. Well, that's 11. But then on line 3 and 4, I'm just using variables instead. You might be wondering, well, why would I do it this way? This is a contrived example of just showing you that you could do it this way. You don't have to do it this way. There's no real advantage to doing it this way in this particular situation. I'm just showing you. But here, I'm adding the variables, A and B, that happen to have the values 5 and 6, respectively. Yeah?
Would it matter what type it is? Would they be A and B? Would they be considered a string? Or because they have the place value 5 and 6, would they be considered integers?
So here, on line 3 and 4, because I'm saying A equals 5, and it's just a 5. It's not a 5.0, and it's not a quote 5. Here, Python would know it's an integer. It's an int. Okay? So 5, 6, and the A plus 5, because it's an integer plus an integer, we get back an integer. So here, Python would know. But, like, do you have experience in other programming languages? You don't. Okay. Does anyone else here have experience in another programming language? Like, what are you used to? C. So if this was C and you wanted to make a variable A to store an integer, that's not how you'd do it. You'd have to be like integer A equals and so on. You'd need to be explicit. But Python's like, yeah, that's an int. Even though it might mess, this type of stuff might mess you up. And I'll show you examples of this as we go. So here, this is an example of Python figuring it out. What other, so someone, is anyone, you use C. Was it C or C++? It was C, cool. Did anyone else here use C before? All right. Does that kind of maybe, C sharp? Oh, that's not, that's it's quite different. It isn't, but it is. So C is actually, okay. There's a little more to it than this, but I'll put it a little simply, a little history lesson. C is old. It's from like the 70s or something, right? Look, do me a favor, check when C came out. It might even be the late 60s. I could be wrong. It's an old programming language. Pardon? 72. Okay, there we go. 72. So it's an old programming language. But it created like basically the standard for like syntax and how we code. That's not entirely true, but for the most part. So you've got this language of, this family of languages, like C-like languages. That would be something like C, C++, Python, Java, C sharp. C sharp and Java, their syntax is almost identical, actually. They are all very similar. Python's actually the most dissimilar from the others, but they're all pretty much, the syntax is very similar. There are languages that are way different. But when people, like if after this class, like next semester, for example, if you take 162, which I highly recommend, we switch to Java. It's a different programming language. Anyone here used Java before? Yeah. So people who aren't used to programming, they're like, we're switching programming. I got to learn a whole new programming language? Oh, man. It's basically the same. There's a little syntactical differences that you kind of figure out as you go, but it's not that different, actually. So, like, how many programming languages do you know is kind of a silly question to ask, because if you know one, you know like 38, just because they're all so similar. Other questions? What other programming language? So you see, I saw Java, you said C sharp. Anyone else have experience with another programming language? Used what? Basic? Okay, yeah, okay, cool. Basic or Visual Basic? Just Basic. That's another old one too. Cool, cool. Yeah. Other languages? Cool, all right, whatever. Those are the big popular ones. Anyone used Fortran before? That's an old one.
I remember back in like middle school, they were teaching us something on our computer, and I think that's something to do with programming. I remember like putting in some stuff to make the character move.
Yeah.
I don't know.
It could have been Snap or something? Scratch. That actually, a lot of people like make fun of it. A lot of like when younger students are learning it, they're like, this isn't real programming. It actually is. It legitimately is. It's got all the foundations, except it's kind of like drag and drop, and you kind of like put the things in to create the, but it teaches you all the concepts and stuff of programming, which is fantastic. Did anyone else use Scratch? Use Scratch, right? Used Scratch before? That's pretty cool, actually. I think it's a really neat programming language. Anyways. All right, here we go. This activity, I'll give you a few minutes for this one because this is a good one. Do these 5 things. You know, take your time, don't rush. I mean, don't lollygag, but don't rush. Assign various variables and types values of type string, integer, and floats to variables. Try adding variables of the same type, different types. Try that line. Figure out how to display the current contents of a variable. Well, that one we probably already know. But I'll give you like 4 minutes to do this one. Raise your hand if you're done. Raise your hand if you'll be done in like 30 more seconds. Cool. So I did number 1. I created 2 variables for each of the types that we've seen so far. I created 2 variables for int, some int, another int, then some string, some other string, and then some float and another float. The values I picked are entirely arbitrary. They're not meaningful in any way. But there's the variables. The next was try adding them some of different types. Well, okay, print some int plus another int. Well, this shouldn't blow our mind. We saw examples of this already. What happens when you add 2 numbers together? You get their sum, right? 5 plus 9, 14. Makes sense. Some float and another float. We add them together, we get 1 plus that. Now, you might actually notice something kind of funny. It looked like it actually kind of like rounded off the last couple decimal points there. It's kind of an interesting thing to note. Oop. And then, okay, again, you're adding numbers together fine, but this one might throw you off a little bit. Some string plus some other string. If I run this and I add them together, what is the addition, like what does the plus sign do? So plus with numbers clearly gave me back the sum, but what did the plus sign do here? Is that the sum of the strings? No, that's a stupid question. What is the sum of a string? No. No. The plus sign for strings actually did something different. It's an operator that we might say is context sensitive. It works one way for things of some types and another way for other types. So if you add 2 strings together, we end up just concatenating them. We just shove them together. It didn't add a space. It didn't do anything other than smush them together. And of course, the order matters. I could do it this way. Nope. And we get blah hello, or blah hello, whatever. Right? Cool. So, okay, add things of different types. So some int plus some float. That one, let's see what happens. Because this one, at least it seems, I should be able to assume, yeah, I assume it works. So 5 plus 1.0 is 6.0. But notice that when we took the integer and we added a float to it, what was the type of the result? It was a float. So it automatically kind of like added the decimals for us, which is interesting. But what if I try to do this? Well, I get a runtime error. Because I'm asking Python, okay, what is 5 plus hello? And Python goes, that's not a thing. I can't do that. That's an absurd statement. So it's saying I can't do that. I can't do plus on an int and a string. That's what that error is saying. And this is what we call a runtime error. It's an error that didn't present itself until the code ran. Now, this is an example. This particular scenario is an example of where having a not strongly typed language, because Python's a little loosey-goosey with the types, it figures things out for you, but if this was C or C# or Java, we wouldn't get a runtime error, we would get a compile time error, meaning this code ran but crashed. In the other languages that are a little bit more strict with types, this code wouldn't even run. I would say it's better to not run incorrect code than it is to run incorrect code and let it fail miserably. So it's better to know that there's a mistake beforehand. And it would know because the language would know the types, and it would know, well, you can't add these things together. So even before it runs, you would know there's a problem. But in Python, it would only show up as a runtime error. Did anyone try number 4? What happens if you do this? 5 equals A. Well, it's going to say you can't assign anything to a literal. So the literal 5 is the literal 5. And I want to take the value of A, which right now, I actually have no idea what the value of A is in the computer right now. And I'm trying to overwrite, I'm trying to put into the value 5 a new value. Well, Python's saying, yeah, you can't do that. I can't change the value of the literal 5 for obvious reasons. And if you say, well, no, really what I wanted to do is I wanted to put the value 5 in A. Well, what's wrong with this? Well, the problem is the left-hand side must be where you're putting the value. So they're just in the wrong order. And how to display the current contents of the variable? Print it out. Any questions about what we just saw there? Everyone's happy? Am I going too slow, too fast?
For the error code.
Yes.
It said, I forget what it said. Yeah, it said, maybe you meant a double, equal sign.
Yes. So a double equal sign, which we will see in like a week or so, but a double equal sign is like a statement of equality. So I would use a double equal sign to check whether or not the value A and 5 are equal. And that would either tell me yes or no. Yes, it is equal, or no, it's not equal. So if there was a double equal sign, I'll show you what it does. I think A might currently be 5, so this might give me back true. Yeah. So that would work. But it's because equals equals is checking, are these things equal? If I were to say 6, well, it's false because A is 5 and 6 is not 5. So to answer your question. But we'll go over this in more detail in like a week, maybe even less. Other questions? The error messages in Python are pretty helpful. Like here, unsupported operand types for plus. You can't add an int and a string, right? Like that's what it's telling you. But when in doubt, do what I do. If I'm ever like, I don't know what this error message means, just throw it into Google. And then there's like literally billions of results explaining what the issue is. Look, there's videos, there's Reddit posts, there's everything. If you have a question, someone's probably answered it before. Okay, naming variables. So all the variables I've shown so far, for the most part, have had pretty bad names. Like A and M and sumint. I guess sumint was fine because it was supposed to just store some arbitrary integer value. But in general, if I'm writing code to solve a problem, like if I want to calculate the density of something, I want to have a good variable name because I want my code to be as self-explanatory as possible. So if I have a variable that's supposed to store the value that represents a density, well, a good name for that variable would be density. So call it density. D, a single letter D is, okay, it's fine, I guess, but not that descriptive because D, what does that mean? I'd have to play a guessing game of what's D mean? Well, in the context, I guess it could be density. You know what's better? Just call it density so it's clear. So there's no ifs, ands, or buts. It's obvious what it is. And something like definitely not density is obviously a terrible name for a variable representing density. If I gave you like an assignment where I say calculate the density, and I see the variable that you use is like A equals the calculation, you're going to be mad at your mark. Because it's not just that your code is correct, it's that your code is correct and good. So good code is stuff like good variable names. Your code should be as self-explanatory as possible. Once we learn more and we see how this fits into context a little bit more, this will become a little bit more clear. But there are some other restrictions that we have to be aware of when it comes to naming our variables. And there are some conventions we'll follow too. So there is a rule, you can name your variables like almost anything you want, but it has to start with a letter. Right? So I can have a variable called variable 1, like that, equals 6. All right? I could do that. But if I wanted like 1, I can't do that. You can't have your variable start with like a number or anything like fancy. It's got to start with a letter. And there are also some reserved words in Python. Like if I were to say def equals 6, right? Maybe I needed the variable def for some reason. I really wanted to use def. Well, I'm out of luck because def is a keyword for Python. Def means something very important to Python. So if I were to try to like change, oh no, def is just a variable storing the value 6. No. So there are some reserved words we're not allowed to use. But other than that, sky's the limit. Do whatever you want, assuming it's a good variable name. There's also some conventions we have to follow. So a variable name, so first of all, a variable name like this clearly it works. But that's a terrible idea. That is a bad variable name, right? So just because it's correct doesn't mean it's good. And there are other things we're going to do. There are some conventions we're going to follow. Conventions that if you don't follow, your code will still work. The only problem is you will piss off every programmer there is. So we're going to follow the conventions. And there's not very many of them. But for our variables, we use something called, we always use lowercase letters for our variables. Don't put uppercase letters in your variables. Only in very special situations would you do that. So we always use lowercase letters. And sometimes you have a variable that you want to have like 2 words in there, like some integer or something. You want like 2 words. Well, if you want 2 words, we separate them with underscores, like I have been doing. Right? Oh, not a plus. Underscore. So that would be like following the convention. It's all lowercase, and we separate words with underscore. This is called snake case, for those of you that care. Now, other programming languages, like if you're used to Java or C#, the convention in those programming languages are a little different. You use something called camel case. We are not going to use camel case for our variables in Python. That's breaking the convention, and we're not going to break the convention. But camel case would look something like this instead. So this is how you would like name it in like Java or C#. If you had multiple words, you always start with a lowercase, but if you have another word, you don't have a space or an underscore, you just start with an uppercase. We are not doing this for our variables in Python. That would break the convention, and we are not going to break the convention. This will work, but it would make everybody mad. Like if there's a Python programmer in the room, they're starting to pull their hair out already because they're like, no, you can't, no, that's bad. Don't do that. This is how we would want to do it. Any questions about this convention here or anything around there? Yeah?
What circumstances would we use capital letters
At the start? I can't think, I don't know, if it was like the FBI most wanted, maybe I'd do like FBI uppercase because it's letters, I don't know. Like maybe in that situation I would, like it would be very special situations where I go like, I guess I could use it here, it makes sense. There's like a joke in programming, how like, there are 2 really hard things to do in programming. The first one is caching, which is something we're not going to do. The second one is naming variables. And it's a bit of a joke how like programmers will spend like shockingly large amounts of time thinking about what they should name that variable. Like, should I name it? No, that's not in line with that. Like it's a bit of a joke. And then the third issue is off by 1 errors, which is also a big issue, but there's a joke there, obviously, because come on, that was hilarious. Do you not get it or are you not listening? One person got it, 2 people got it. All right, it'll come, this joke will come up again later. Maybe you'll get it next time. All right, other questions? All right.
What do some of the keywords stand for?
Def, so there's a lot of them, and without having a list in front of me, I couldn't tell you offhand, but like def is like define. So that's what we use for like defining a function.
What would ELIF?
Elif, that is else if, which we'll learn about very soon. Yeah. Do you have other ones? No? There are a bunch more like init, initialize, and int, well, that means like integer, that's the type, and so on. Yeah. So constants. So I'm going to show you an example of constants. So let's say I've got this code right here, right? Now, in this particular example, I look at this code, and there's a variable called SUMBILL, and there's another variable called another bill. And the top one is 1045 times 1.15, and the second one is 499 times 1.15. Now, you, with the context of this code, the name of the variables, I'm willing to bet you could figure, like, what is that 1.15? Who can make a guess as to what that is? Yeah, the tax, right? Right? So in this context, you probably know what it is. But at the end of the day, there is a bit of a guessing game, like times 1.4. Like if I'm from somewhere that has a way different sales tax, I'm going to be like, what is that? Oh, what's that? I have no idea what that is. It's confusing. It's unclear. And this would be a good candidate, this particular situation would be a good candidate for the use of a constant. Now a constant, it's just a variable. It's only a variable, but we have a special convention for constants. It's this. It's all uppercase. Okay? And separate with underscores. So this, right here, this tells all the programmers that would be looking at this code, not just you, the person writing the code, but any other programmer looking at your code, they would see, oh, it's all uppercase, it's a constant. And a constant means once you set that value, you can use the value stored in the variable sales tax, but you're never supposed to change it. You're supposed to just leave it the hell alone. So now I could do something like this. Now, like this could be online like 5 billion of your code, right? So imagine you never saw sales tax equals 1.15, but I show you this code. I would argue this is a hell of a lot more clear as to what this code is doing. What is it for? Well, SUMBILL is, okay, 1045 times, oh, the sales tax. Oh, okay. And again, any programmer goes, oh, that's some constant value, great. I'm not supposed to reassign what sales tax is. But a constant is a really great way to effectively name a value. Like you give a value that has some important meaning, you give it an explicit name, it removes any ambiguity about what the hell that 1.15 is. Oh, it's sales tax. Why? That's what it's called. I mean, unless the programmer was really trying to trick me, they wouldn't call sales tax unless it was the sales tax calculation. Another thing that would be nice is, let's say next year they decide to lower the sales tax. And I've got a program that's like 10 million lines code, 10 millions of, it's like millions and millions of lines of code. So much code. And I'm doing all this calculation based on the sales tax. And the government changes the sales tax to 14%. And I go like, shit. Now I got to go and change how much code? No. You have to change one line. You scroll up to the top and you go like this. Oh, done. I only had to change one line of code. And now it's updated for every calculation there is because it's using the constant variable sales tax, which is really nice. You might say, oh, I could have done find and replace. Okay, fine, whatever. But what if there was another 1.15 in there and you meant to change that too? Oh, it's a nightmare. This is just way better. So a constant is great for the fact that, like, okay, it's a constant value. It's great because it's a way to tell programmers, here is a value, don't touch it. You can use it, but don't change it. You leave it alone. What I mean by that is, if you ever see a variable that looks like this and you do something like this after, oh, now it equals 88. You're a bad person. Because this is a constant. I know it's a constant because it's all uppercase. That's how I tell other programmers this is a constant, leave me alone. I can run this code, it'll work, but I've broken the rules. And that's my fault because I changed it. I can use sales tax, but I'm never supposed to change it once it's been set. So constants are a great way to signify here's a value, leave it alone. It's another great way for giving an explicit name to a value. And it's great for examples, for situations of like, oh, they changed the sales tax. I only need to change it in one spot for it to update everything else. In other programming languages, if you have a constant, there would be a way to specify that there's a constant. And it would actually prevent you from changing it. Like your program wouldn't run if someone tried to change it in the code. Python won't do that. It'll let you shoot yourself in the foot if you want. But anyways, constants. All right, I'll see you all tomorrow.